Welcome back to Decode Tech and another Python programming video. So far we've had programs that do pretty much the same thing every time we run them, and now we know how to accept different kinds of input, which makes them more interesting, but the programs still always do the same thing with that input. We need a way for decisions to be made in our code. So there's if statements, or otherwise known as branching, in Python and almost all programming languages. So programs often need to be able to do different things depending on the input. For example, if the answer is right, do something. Or if the car hit the tree, the car state now equals crashed. Or if a file is missing, give an error, etc. And to make these decisions, Python or programs do a check/test to see if the specific condition is true or not. So there are only two possible outcomes, true or false. And this is often known as Boolean values, either true or false, on or off, 1 or 0, which maps really good for computers because if you watch my How a Computer Works series, you know that there's bits underneath the scene, and a bit is either a 1 or a 0. So doing these tests and making decisions based on the results is called branching, because you can think of it like a train track. If a train is going down the tracks and it comes to a switch, it can take either the one track or the other track. It's the same way in the program. If it comes to one of these if statements, it can either go one way in the program or a different direction. And that'll hopefully make more sense here shortly. So let's say we have a class, and in this class we have Tom, and he took a test. So we want to see if Tom answer equals the correct answer. And if we want to see if Tom's answer equals something, we probably know what that something is, so we'll assume we know the correct answer. So now how can I test if Tom's answer equals this correct answer variable? Well, to do that, I'm going to copy this and just paste it into a new file. So now I'm going to do Tom's answer equals 55, and oops, I got a random Z in there. And I'm going to do the correct answer equals 102. Now Python has something called if statements. So if we want to check if something's correct, we can start with the keyword if, and then the condition we want to test. So this will be either evaluated to true or false. And by the way, this if I said is a keyword. So keywords in Python are reserved words for Python that we can't use because they have specific uses in the Python language. So we have if and then the condition. So we want to see if Tom answer equals correct answer. So if this evaluates to true, something will happen. And if it's not true, it'll just get skipped. So at the end of my if statement, I have a colon here. This is very important and easy to forget. And what that colon means is a block of code is coming. And a block of code is just one or more lines of code grouped together that are related to a specific thing in your program, such as an if statement in our case. And there's other things in Python that take blocks of code, and we'll look at those later in this tutorial series. Now these blocks of code are formed by indenting code to the same margin. So if you tabbed in each line to the same length, they'll all be in that block of code. Now you notice that my cursor automatically got indented for me in idle here when I hit enter going on to the next line. I'll do it again because this knows I need a block of code, and so it already indents the first line for me. Now in Python, the indentation convention is 4 spaces. And so idle, if you go under options and hit configure idle, you'll see that under fonts and tabs, a tab is already configured to be 4 spaces because it knows that Python convention is 4 spaces. And so most editors you use, you can configure the tab spaces. If not, you just press the space bar 4 times and that'll give you the correct spacing, although that's kind of a pain to do. So it technically does not matter how many spaces your block is indented, as long as all the lines in the block are the same indentation. But as stated before, 4 is the convention, and a convention is just something almost everybody does. So it's smart to do it, because if somebody uses your code or you use their code and your spacing is different, it can be a real pain. Now, in many programming languages, this indenting is just a matter of style. In other words, it makes it easier for humans to read and understand what's happening with the code. But in Python, it's more than just a style, it's actually required. So it can break your code if you don't indent properly. It'll probably give you like an indenting error or something like that. So whatever we want to run, if this above condition evaluates to true, we put in this code block. So I'm just going to say print correct. So let's save and run this. And it's going to ask me where to save it because I just started a new file. I'm going to save it under my tutorials, and I'm going to name it condition.py. Now if I run it, you see I get a prompt right away and we had no output. That means it did not evaluate to true. That's because Tom's answer was 55 and the correct answer was 102. If I change his answer to 102, save and run again, we get correct printing to the screen this time. Now if you put something outside of the code block, so in other words, indented the whole way to the left edge again, like another print, this will evaluate whether the above statement is true or false, because it's outside of the block of code reliant on that condition. So I'm just going to print always will print. So I'll run again, and you see we get both lines of output. Now if we change Tom's answer to be wrong again, the bottom print will still print. So remember, if statement starts with the if keyword, then the condition, then the colon, then that means an indented block of code is coming, and this block of code is related to if this condition is true or not. All right, now I want to talk about comparison operators. So you might be wondering, are you seeing correctly that I have two equals sign or double equals sign here? And you are seeing correctly. That is the equality operator, or there's a new set of operators called comparison operators. We looked at math operators before, like the plus sign, the multiply sign, all those. These are comparison operators. And some other ones are not equals, which is exclamation point equals, greater than, less than, greater than or equal to, less than or equal to. And you may have seen a lot of these in school, so they might be intuitive already. But if not, you can always do a quick Google search, and I think you'll soon learn to memorize them. So this is equals, this is not equals, this is greater than, less than, greater than or equal, less than or equal. All right, here's something else. You can have a variable in the middle and have two conditions on either side. So for example, this would read, if Tom's answer is greater than 88, and if Tom's answer is less than 96, then do whatever's in the block of code. So what I'm saying is if his answer, or it'd make more sense to do grade rather, then I need to change the variable up here to be grade. If Tom's grade is between an 89 and a 95, he got an A. So I'm going to print Tom got an A. And so it can't be 88 or 96. So let's run this and see if he got an A. Now you see we got a type error here. It says not supported between int and string. You need to be very careful when you're comparing types, because two different types will never be equal. If you're doing equality, if you're trying to compare an integer of 5 and a string of 5, they will never equal each other. That can really cause a lot of confusion. So let's change this 95 from a string to an integer, and I'll run it again. And now you see he got an A because 95 is between 89 and 95. Now if we change it to 96, it won't work because we don't have less than or equal to. We just have less than 96. And you see we got no output. Now what you can do is use another keyword outside of the code block called else, and this else is tied to this if statement. And now else just means if it's anything else, so I don't need a condition after it. I can just say else colon, which means a block of code is coming, else print he did not get an A. And now you see the else printed out. All right, what if you wanted to test two different conditions? Here we're just testing two different things based on Tom's grade, but what if we tested on his grade, or his score rather, and the grade he's in at school? So we're going to do Tom's score and Tom grade. So let's say he's in 6th grade and he gets a 95. So we could say something like, if Tom grade equals, remember the double equals, 6, then do whatever in this block. And in this block, we can do another if, or a nested if. If Tom score equals 94, then print both are correct. So now both of these have to evaluate to true for this inner print to print out. And notice that the print is 2 tabs in, not just one, because each if statement needs its own block. So it needs to be inside the second if statement. Now if I run this, nothing prints out, because although Tom's grade was 6, Tom's score was not 94, so therefore it did not print anything out. If we change this to 95, we should then see it print out to the screen. And sure enough, it says both are correct. Now there's a better and shorter way to do this with the AND keyword. So in the first if statement, we can say and it's another keyword in Python. You see it highlights, but it's also called a logical operator. So we had math operators like plus and plus and multiply and all those. Then we had comparison operators like the double equals, the greater than, the less than, and now we have logical operators. There's and, not, and or as the 3 most common. So and means both conditions have to evaluate for true for the block to execute. So if I do and Tom's score equals 95, that'll be saying the exact same thing. So now we can get rid of this second if and pull this print back into the main block and run it, and we should get the same output. And it's correct. Now, if I make Tom's score wrong and change and to or, now only one of these conditions has to evaluate to true. And so in this case, we should get 1 is correct. So I'll change it from both correct to 1 is correct. Let me run it again. Now we get 1 is correct. Now if both are wrong, then nothing will happen. And you see nothing happened. Okay, so I showed you a little bit the else keyword that you can put at the end of an if statement to do something if it's not true. Or you can do what's called an else if to test multiple conditions in the same if block. So for example, we could do if fav color equals blue, then print blue is my favorite color. Now, if you go back to the far left again outside of the if block, you can do elif, short for else if. Now your new condition, fav color equals orange, colon. Now you get a new block, say print orange is my favorite color. And now, if we wanted to catch all other conditions, we could plug an else in. And remember, else doesn't need a condition because it's just catching everything else. So we just do a colon right away, get a new block, and we print none of these were my favorite color. Now you can have as many elifs as you want. There's no limit in Python, but I'm just going to use one for this example. So we have favorite color as orange. So let's run this. And you see it prints out orange is my favorite color. So Python reads the file from top to bottom. It says if favorite color equals blue. Is that condition true? No, it's not. So we go on to the elif. Is favorite color equal to orange? It is. So it prints orange is my favorite color. Now the way these if, elif, else blocks work is if as soon as it finds a condition that is true, it'll just evaluate that code block and jump out of the if, elif, else block. For example, if I change favorite color to blue, as soon as it comes to this line and sees that it's true, it'll just print this out and then jump down to below the else. So let's see if that happens. Sure enough, we get blue as my favorite color and nothing else here printed out. Now let's try a color that's not in any of the conditions. Let's try green and see if our else works. So let's change this to green. Now the else, none of these were my favorite color, prints out. So that's working fine. All right, so that is the basics of if statements and branching in Python. So I have a little challenge here for you to try out, and that is if you did the temperature conversion program where it converts from Fahrenheit to Celsius, modify this program and take user input for the Fahrenheit temperature. Then once you get your Celsius value, write some logic that handles this. So first of all, if Celsius is less than or equal to 0, which would be 32 degrees Fahrenheit, have your program display it is freezing outside. Else if the Celsius is greater than or equal to 15 and less than or equal to 30, display it is very pleasant outside. Else if Celsius is greater than 30, display it is extremely hot outside. All other scenarios display I'm not sure if you enjoy the weather. So then test your code and have fun with it. Obviously, you're going to need to use the concepts we talked about today. And I didn't use any input on the examples in today's lesson, but you could just as soon take the favorite color in as user input as well. So go ahead and try the challenge out. And then once you're done, if you think you figured it out or just are interested, I have a solution here that I'll show you once you unpause the video. So go ahead and try that now. Alright, so here's the solution I have. I'm taking user input with the input function, asking for the Fahrenheit degrees, converting it to a float right away, storing it back in a variable called F for Fahrenheit. Then I have my Celsius to Fahrenheit conversion formula. I have C gets 5 divided by 9 times Fahrenheit minus 32. The Fahrenheit it's going to get straight from this user input, and we're storing it back into a variable called C. Then I'm saying if C is less than or equal to 0, print it is freezing outside. Elif C is greater than or equal to 15 and C is less than or equal to 30, so both of these conditions have to evaluate to true, print it is very pleasant outside. Elif C is greater than 30, print it is extremely hot outside. And else, print I'm not sure you enjoy the weather outside. So then this will handle all the conditions I have written over here. One thing to keep in mind is that you're using Fahrenheit temperatures to enter into your program. So don't enter 0 and expect that your first condition should be operated off of 0 because it's getting converted from whatever you enter to the Celsius value. So if you entered 0 Fahrenheit, it would be negative something Celsius. So just keep that in mind. That kind of confused me when I was first testing my script. So if you enjoyed the video, please give it a thumbs up. It really helps the channel out. If you're not already and you like this, maybe check out some other videos first. And if you want to, if this channel looks like it's your style, you can subscribe and share the video with anybody that might find it useful. And hopefully we'll see you in the next Python tutorial.